In combinatorics, one excellent topic is distributions. And when we say distributions, there are different varieties. We can first consider equal distributions. Let us try to understand this concept. Suppose I have 10 different books. Books are numbered 1, 2, 3, etc. Now 10 different books are to be distributed among two boys A and B equally. Now, that there are 10 different books, the books are numbered 1, 2, 3, etc. 10, and we have two boys A and B, and we want to distribute these 10 books to two boys A and B equally. So, how do we do it? Suppose A chooses any 5 books out of the 10 different books, B automatically takes the next 5 books. So, A can choose any 5 books in 10c5 ways, that is 10 factorial by 5 factorial into 5 factorial. Let us examine this 10c5 little more closely. Suppose A chooses books numbered 1, 2, 3, 4, 5. B automatically chooses 6, 7, 8, 9, 10. This 10 factorial by 5 factorial whole square includes a case where A chooses 1, 3, 5, 7, 9. In that case, B automatically chooses the remaining 2, 4, 6, 8, 10. Like that, whenever A chooses any 5 books, B automatically chooses the remaining 5 books. So, this distribution can be done in 10 factorial by 5 factorial whole square ways. In this, one more point is to be observed. Suppose A chooses 6, 7, 8, 9, 10. In that case, B automatically takes 1, 2, 3, 4, 5. Suppose A chooses 2, 4, 6, 8, 10. A automatically takes 1, 3, 5, 7, 9, etc. So, that means what I am trying to tell here is not only dividing the 10 books into 2 equal parts, the set interchanges are also included in this 10c5 or what we call 10 factorial by 5 factorial whole square. So, if A chooses 1, 2, 3, 4, 5, B is automatically taking 6, 7, 8, 9, 10, and if A chooses 6, 7, 8, 9, 10, B is automatically choosing 1, 2, 3, 4, 5. So, this 10 factorial by 5 factorial whole square is not only dividing the 10 books into 2 equal parts, the set interchanges are also included in this. So, in general, if we have mn different objects, and if they are to be distributed equally among m persons, it can be done in the following ways. See, of the mn different books, the one person randomly can take any n items. Of the remaining mn minus n items, the another person can take again n items, another person can take like that. The last person, when it comes to last person, you will be left with n books or n items. So, it is like this. So, this becomes mn factorial by n factorial into mn minus n factorial into mn minus n factorial by n factorial into mn minus 2n factorial, etc., etc., n factorial by n factorial into 0 factorial. So, all these things get cancelled and you get mn factorial by n factorial whole to the power of m. So, the number of ways in which we can distribute mn different objects among m persons equally such that each person gets exactly n objects is mn factorial by n factorial whole to the power of m. In the example that we have given, we are distributing these objects to people. But suppose instead of distributing these objects to people, suppose we are distributing them into identical boxes, let us say. If we are distributing them into identical boxes, what happens is, once you keep some books or the objects into a box and some objects into another box, and if the boxes are identical, interchanging of the contents has no impact. So therefore, in the earlier example that we have discussed, if 1, 2, 3, 4, 5 is taken and 6, 7, 8, 9, 10, this is taken, if they are instead of A and B as persons, suppose they are identical boxes, then this case is not required. If this case is there, this case is not required. So 2 factorial th of cases are getting reduced. Similarly, if there are 3 boxes and if you are distributing 15 objects and each box containing 5 objects, then 3 factorial th of it will be reduced. Similarly, if there are m identical boxes, the number of ways in which this can be done is mn factorial by n factorial to the power of m into m factorial. Now let us see one problem here. In how many ways can we distribute 10 couples into 5 identical boats? Each boat can accommodate 2 men and 2 women only. So in how many ways can we do it? So we have 10 couples and there are 5 identical boats and each boat can accommodate 2 men and 2 women only. So in how many ways can we distribute this? So there are 5 identical boats. There are 5 identical boats. So that 10 men can be distributed in 5 identical boats in 10 factorial by 2 factorial to the power of 5 into 5 factorial ways. Because the boats are identical, this 5 factorial comes now here. Now, in how many ways can we distribute the women? The common mistake that usually students do is, the women also will be distributed as 10 factorial by 2 factorial to the power of 5 into 5 factorial. This is not correct because the moment you distribute men, the boats are no longer identical, because by virtue of these people sitting in these boats, the boats have become distinct. So this 5 factorial need not be written. So the answer becomes 10 factorial by 2 factorial to the power of 10 into 5 factorial. In so many ways, we can distribute 10 couples into 5 identical boats.